going to do problem number 1 on chemistry worksheet, limiting reactant worksheet number 1. So all the information, 2 ALs with 6 HBRs produces 2 AL, BR3, 3 H2s, looks like it's balanced. What's different about these problems with limiting reagents is that when you read the problem, you've got 3.22 moles of AL and you've got 4.96 moles of HBr. So you have 2 numbers. The problems we've done previously just had 1 number. So we have to figure out which one is the limiting reagent because that's the one that we'll use for all of our calculations. It doesn't matter which one you pick. I just usually pick the first one. So I'm going to take 3.22 moles of AL down and I'm going to try to figure out if it is the limiting reagent or if it is the HBr. So I'm going to convert to HBr. I use the mole ratio, so 2 moles of AL goes on the bottom, so that goes away, and HBr is 6 moles, so I put that on top. I'm going to go ahead and do the math, and that is 9.66 moles of HBr that I would need to react with the 3.22 moles of aluminum. If I look back in the problem now, I only have 4.96 moles of HBr, so that's not nearly enough. That means that HBr, because I don't have enough, I don't have as much as I need, HBr is my limiting reactant. Okay? The other part of that question is how many moles of H2 are formed. So I have some more work to do. I know which one is the limiting reagent. So now I'm going to use the HBr amount. I'm going to ignore the aluminum. I'm going to take the 4.96 moles of HBr because it is my limiting reagent, and I'm going to convert that to moles of H2. So again, I need to use my moles to convert. So I'm going to put 6 moles of HBr on the bottom. That's a 6. And I'm going to put 3 moles of H2 on top because that's what they asked, how many moles of H2 are formed. So we've got some math to do there. And it looks like that would be 2.48 moles of H2. So this is my answer to A. This is my answer to B. And now we're going to go on to C. So the question for C is, for the reactant in excess, how many moles are left over? So remember, HBr is our limiting. If you go back to the equation, the only other, so this is our limiting, the only other reactant is aluminum. So this is our excess. You'll have 1 limiting reagent, you'll have 1 excess. So we're going to have leftover aluminum. They want us to figure out how much. So again, start with your limiting reactant, 4.96 moles of HBr. I got that from the problem. It was given right here. So I'm using that, and I'm going to convert and figure out how much aluminum I need. So again, I'm going to use my mole ratios. HBr needs to go on the bottom, 6 moles HBr. This time though, I want to convert to aluminum. So I'm going to use aluminum, which is 2 moles. And when I do that, I end up with 1.65 moles of aluminum needed. So to react 4.96 moles of HBr, I need, whoops, I forgot the aluminum, 1.65 moles of aluminum. They asked, though, how many moles are left over. So I have to go back to the original problem and look at how much aluminum they told me I have. I have 3.22 moles of aluminum. Up here, I said I need 1.65, so I simply subtract. 3.22 is how much I have. 1.65 is how much I need. And that would mean that I would have 1.57 moles of aluminum left over. Okay, now I added this last one. Percent yield is another thing that we added and I've started looking at. So the question says if 0.851 grams of H2 are actually produced in the lab, what is the percent yield? So the first thing we're going to have to do is figure out the theoretical yield. That's where we do stoichiometry. We figure out how much the yield should be, how much should be produced on paper. So I'm going to take that 4.96 moles of HBr that is our limiting reagent. I'm going to convert to H2 again because that's what they're asking me about. So 6 moles of HBr on the bottom and 3 moles of H2 on top. And then I need to get it into grams of H2 so that I have a theoretical yield, and then I can divide by, divide with the actual, what we actually got in the lab. So a mole of H2 goes on bottom. H2 has a mass of 2. I got to do the math here really quick. So we'd have 4.96 times 3 divided by 6 times 2. So it'd be 4.96, didn't change, grams of H2. Now, if I go here and look at my actual yield, I'm going to take that, I'm going to go 0.851 grams of H2, which is what I actually got in the lab, and then I'm going to divide by the theoretical, which is what it says I should get on paper, and then take it times 100. So again, I'll do a little math here. 0.851 divided by 4.96 equals times 100. It is a 17.2% yield. And that is not good. You would want to yield, you want a yield of 90% or more. You want it to be on paper. Sometimes you don't get the yield that you want because it escapes. This would be especially true with a gas. You have a hard time collecting all of the gas that's given off. It might be impure materials. There's lots of things. So 17.2 is a bad yield, but based on the information they gave us, that's what it is. So there's an example for you. Send me a message if you have questions.